Okay, so we've already talked about this a little bit, pathogenic variability. So this is one of the things that the surveys tell us, where the variability is being generated. How do these new pathotypes arise? If we understand the pathogens better, then hopefully we can develop better strategies for better approaches to resistance breeding. All right, so we know that our long-term studies, so we've been doing this work nearly for 100 years now in some parts of the world. And that work has told us that, sure, these things are undergoing sexual recombination in some parts of the world. Puccinia graminis, as I said, on Barbary. Puccinia striformis, also on Barbary. Exotic incursions. This is where we get a rust isolate, a pathotype that gets introduced into another region a long, long way away, either through long distance dispersal by air, by wind currents, or, as I said earlier today, contaminated clothing. Migration within epidemiological zones. We've seen this with UG99. It's gone from its original location in Uganda, and it's spread all the way down into South Africa and up into Yemen and up into Iran. So this is migration within an epidemiological zone. Hundreds if not thousands of kilometres. Mutation's an important one, and also a process known as somatic hybridisation. In most regions, the work that we've done would suggest that mutation is the #1 process generating variation in these rust pathogens. Frequencies of sexual recombination, somatic hybridisation and exotic incursion are thought to be low. Now, I could be wrong on that, but this is what our studies to date have indicated, that mutation is probably the #1 driver of genetic variation in rust pathogens. Now, when we look at sexual recombination, so I'm going to go through, what I'm going to do now is I'm just going to go through and discuss each one of these, okay? From 1 to 5, each one of these processes. So first of all, and you've had a pretty good go on this today already, sexual recombination. This is the wheat stem rust life cycle. And here are the eciospores that are coming off Barbary, right? Potentially, each one of those eciospores could be a different pathotype. Each eciospore is a different genotype. Each could be a different pathotype. So if you took 100 or 1,000 eciospores off a Barbary plant and it was Puccinia graminis, former species Triticite, you could have 1,000 different pathotypes. Huge variation. Some of that variation might be important because some of those isolates might carry a lot of virulences, but equally a lot of them might carry a lot of avirulences and have absolutely no importance for wheat varieties at all. But this is an important mechanism, even though it doesn't appear to be very common, right? It is an important mechanism for generating genetic variation. And that's why, in many parts of the world, there have been big campaigns to get rid of Barbary. We don't want it growing near wheat crops. In the US, 60, 70 years ago, they had a massive Barbary eradication campaign where they went out and destroyed thousands and thousands of bushes to get rid of them throughout the Midwest. And that had a huge impact on diversity in the pathogen population. They went from a situation of having many, many pathotypes. This day, in age, very, very few. The pathogen diversity has gone right down as a result of the removal of Barbary. Just some pictures of Barbary. You've already seen these. The big question is, when you do find E-seal cups on Barbary, what are you actually looking at? There are quite a few rusts that actually do undergo sexual recombination on Barbary. All right, exotic incursion. This is where we get isolates being introduced to a new epidemiological zone. Australia is fantastic for looking at this because we are so isolated from other parts of the world. You can see that here. Way down here all on our own, okay? And this is just 3 examples of exotic incursions that we've had of wheat rusts into Australia. So in 1979, there was, for the first time ever, we had stripe rust in Australia. Prior to 1979, never found stripe rust on wheat. The race analysis that was done at the time identified this pathotype, and we suspect it came from Europe based on the pathotype. And some of the molecular work we've done supports that idea as well. In 2002, we had a second pathotype of stripe rust turn up in Western Australia, completely different pathotype, and we believe that came from North America. Way back in 1969, we had 2 stem rust, wheat stem rust, Puccinia graminis tritici pathotypes appear in Western Australia that were very, very different to anything we had in the country. And we believe that these came from Central Africa. How did they get to Australia? Well, in the case of stripe rust, we believe they came in on contaminated clothing. In both cases, we think that those isolates were walked into Australia accidentally. And those 2 incursions had huge effect on our wheat industry. They've cost our wheat growers and the wheat industry millions and millions of dollars, just 2 exotic incursions. A lot of breeding programs had to throw out a lot of germplasm, farmers had to spray crops, we've had mutations in those pathotypes, varieties have been lost, just as a result of 2 exotic incursions. The ones in 1969 from Central Africa, we believe most likely came on high altitude winds. So we know this, and Dave Hodson's done a lot of work on modelling wind movements and maybe talking a little bit about that in your presentation, Dave. But we know that it's possible that there are movements of wind or air, parcels of air, at these latitudes around the Earth that can circle the Earth in 10 to 12 days. And of course these spores remain viable under normal ambient conditions for up to 2 weeks. So it's not beyond the realms of possibility. We believe this is the case because the pathotypes that were found here, there were some comparative studies done at the time, and they were very common, very similar to pathotypes that were common in this part of Africa at the time. All right, so there's 3 examples where we've had foreign rust isolates, wheat rust isolates, come into Australia from other parts of the world. And in fact, we've had more than that. I should make this now 12. So we started our rust surveys way back in 1915, and since then we've actually found 12 cases where we've had exotic incursion of wheat rust isolates. The 12th one I found last year in October. It's a wheat leaf rust isolate that I found in South Australia. We've got no idea where it came from, but it's clearly an exotic incursion. The thing to notice about this graph, which just shows the number of incursions over 20-year periods, is that the frequency is going up, right? And we believe that this is probably related to greater movement of people, air travel, right? Greater movement of people around the world, and human-mediated transfer of rust. So we're getting more and more of these exotic incursions in Australia as time goes by. It's becoming more frequent. We think it's probably related to more movement of people around the world and more people not washing their clothes. I shouldn't say more people, but people not washing their clothes before they come to Australia. So if any of you come to the BGRI meeting in Sydney in September, wash your clothes before you come, please. And equally, if you come to PBI, to my institute, wash your clothes before you go home, right? And your shoes, everything. That's what I'll be doing before I go back to Australia when I finish my visit here. We don't want these exotic incursions. We don't want UG99. We don't want anything, any new rust isolates in Australia.